for engineering or similar career, you'll learn more about different kinds of machines that are used to produce the objects that we use in our everyday lives. So for example, very common are machines like the milling machine and the lathe, which we'll talk about today, as well as other things like laser cutting and water jet, which are used to produce parts, for example, out of sheet metal. So first, I just want to talk to you about conventional manufacturing. And when you hear about 3D printing, you'll often hear it referred to as like additive manufacturing, as opposed to this other type of manufacturing, which is called conventional. And so like, what's the difference between so-called conventional manufacturing and things like 3D printing? As you know, with 3D printing, it's called additive manufacturing because you're building the object up layer by layer. It's like you're adding material up from nothing to build your final structure. And so with most devices that are used for this kind of manufacturing, you have your material, for example, like a spool of plastic that's extruded through the nozzle. And this is used to slowly build up and bond together layers of material that form the overall structure. And this has a lot of properties, like you can control what the inside of the object looks like exactly, because that's what happens when you slice the object into many layers. Now, this was a relatively, I guess nowadays it's not that old, or not that new, but compared to previous methods of technology, which are called conventional manufacturing, this is very different because in the past, one of the ways that we would manufacture things is called subtractive manufacturing. So kind of in opposition to additive manufacturing, instead of building things up layer by layer and slowly adding material, you start with stock material. So a big cube or cylinder of steel or aluminum is what you would start with. And then you'd use your tools and machines to cut away material from that stock to the final shape that you want. So it's kind of like the opposite philosophy of 3D printing, where you start with more material than you want in the end. And as you might be able to tell, it's harder to control exactly what the inside of the object looks like because you're only building it down from a larger piece of material. So earlier I mentioned milling machines and lathes. And so if you decide to pursue some kind of CAD-based engineering career, you'll quickly learn about these two machines. And they're used to make very many parts are made using these two tools. So the milling machine is seen in like this first picture. It's a close-up of what you can see here is the cutting tool, which is this spiraling steel piece. And you also have the work, which is the piece of metal that's being cut. That's what's going to become your final part. And you have a vise that's holding the work. And so as you can kind of see in this animated image, you have a cutting tool that spins and it removes material by moving around and cutting material away from the initial piece of stock that you started with. There's also the lathe, which is kind of the complement of that. And with a lathe, what happens is you put the work, and so in this image, you can see that you have some cylindrical piece of stock that you want to make your part out of, and the machine makes that spin very, very fast, and the tool stays still. So as the work is cutting, or as the work is spinning, the tool cuts away the material because it's moving very fast against the surface of the stock. And as you can imagine, this is useful for when you want to make more circular parts. And finally, one more thing I want to mention is something called CNC, which you also may have heard of. It stands for Computer Numeric Control. And it's a system that allows these machines, like the milling machine or the lathe, to be controlled very accurately by a computer. And so as with for 3D printing, it also uses G-code, which you may have known about. And the result is that you can produce very consistently, much more efficiently, these complex and precise parts that you might not be able to do by hand. And so this brings us to the idea of computer-aided manufacturing. And so keep in mind that CAD, what you're doing with modeling parts in Onshape or another software, stands for computer-aided design. And so computer-aided manufacturing is kind of a natural step forward from design, because once you design your part, you want to be able to make it. So there are lots of different software programs, not Onshape, but many CAD programs also have CAM packages that allow you to program CNC machines, and it creates like the G code that tells the machine what you want it to do. And so I'll do a little like demonstration of what that might be like. Here I have a software called Fusion 360. It also has a very robust CAD package. So it's similar to Onshape in that you can create your different objects and parts using the very similar like sketching and extruding and revolving and all these features. But it also has a CAM package, which allows you to tell a machine how to manufacture something. And so right now I'm in that kind of workspace right now. And you can see in the same analogy of making a part model using things like sketches and extrudes and revolves, I'm able to do things that are called operations. So I can tell the machine that I want to face, which means remove material in a straight plane, or other things like drilling holes. And just like that, I can create a kind of list of parts that I want to make the machine make. And so as I go through each of these contours, you can kind of see these lines, which are the tool paths that the machine will be told to do based on the G code that I generate. And to kind of give you an idea of how CNC milling works, one thing Fusion lets you do is create this kind of simulation. So let's say that I started with some piece of steel that's in the shape of this green cylinder. And then what would happen is the end mill, which is the cutting part of the milling machine, that's the little gray transparent cylinder, it would come in and slowly remove material in the way that you're seeing. So kind of very different from 3D printing. Instead of adding things up layer by layer, as you may have seen before, with conventional manufacturing, we have this tool that's removing material away from the stock to produce the final shape that you desire. And so that's just kind of a simple demonstration of how CAD goes into CAM, and that goes into making a part in real life out of metal. One last thing that I want to tell you guys as an application of CAD is something that's called computer-aided engineering. And so if you're very interested in CAD and you want to study mechanical engineering, this is something you'll do a lot of, because when you design something, how do you know that you've designed it correctly, right? There's a lot of different rules and parameters that decide whether or not your part is good enough and it could be used as a real product. For example, a very obvious one is like structural analysis. So if I design a chair in CAD, I can make the chair as weak or as strong as I want. I can make the legs very, very thin, and there's nothing stopping me from doing that. And so the reason that computer-aided engineering and specifically analysis exists is to tell me if the thing that I designed will behave the way I expect it to in real life. So to the right, you can see kind of standard outputs of a program that you might use for CAE that might tell you like how your part will behave when it's under a certain stress or under a certain load. And these are just kind of words that you might see if you decide to study further. Things like finite element analysis or computational fluid dynamics are words that refer to generally computer-aided engineering. And so if you ever see that, now you'll know kind of what it refers to. And that's my short little introduction about what applications CAD has in the real world. If there are any questions, I'd be happy to talk more about any aspects of the things that I just discussed.
I have a question.
Okay.
I just joined because I was late. So what are we doing?
Right. Up to this point, I've just talked about some of the applications of CAD. And so just to briefly go over, like one of the obvious ones is manufacturing parts. And so for this class, we'll talk about 3D printing later on, but there's also something called conventional manufacturing, where CAD is very useful to tell you what kind of parts that you're going to make. And there's similar applications like computer-aided manufacturing and computer-aided engineering, which are both contained in some kind of software package similar to your CAD, and is used to make sure that you can make a real object in real life based on the things that you model in a program like Onshape. If there's anything else you're curious about, just speak up. And in a moment, we'll move on to the next part of the class. All right, so I'll take that as you guys are all good.
Oh wait, you were asking me?
Or just anyone, if you have any questions or curiosity. But we'll move on. So for the rest of the class, we'll be working on the final day of our little air engine. And by now you'll have many of the parts modeled in CAD. And the goal for today is to assemble the engine. So we'll get something like this. I've gone and assembled it with all the parts, and the final product will look something like this. And so as you can see, you'll have your flywheel spinning, the crank wheel driving the piston, or I guess the piston driving the crank wheel around. And hopefully by the end of the class, all of you will have something like that. So as we get into it, as you recall, the homework from last week was to make either the flywheel or the upright. And so if you had any problems with that or something you want to work through together in class regarding these two parts, please bring it up. Were you guys able to successfully model either of these? Maybe if you did, like, you can type which one you did or say something. Nice, I see someone made the upright. Okay, so no one has any problems with their model of either the flywheel or the upright? Yeah, seems good. So at this point, you've made 6 of the, or I guess you made 5 of the parts, which is pretty good. And so in principle, there is one part left that you have to do if you did one of them. And so for the purpose of this class, we're going to focus mainly on the assembly. And so for the part that you didn't do, if it's the flywheel, if you made the upright, or the upright if you made the flywheel, and if there are any parts that for some reason like you don't have, we posted all of the step files for the parts on Google Classroom. And so what I want you to do right now is to download and import the parts that you don't have into Onshape. So I want you all to make sure that you have all 6 parts, which are listed on the slide. There's the base, the upright, the cylinder, the piston, and the crank wheel, and the flywheel.
Wait, where do you download the stuff? Because I have like a few missing.
Yeah, we posted all of the files just in case, but let's see. You can see there's a post in the Google Classroom called Air Engine CAD files.
It doesn't show that files for me in Google Classroom.
All right.
For me, it's still like the winter 2021. What's the code for the new one?
The code is here. NIUXPL7, I guess. I'll paste that into the chat for you. Is everyone able to access the Google Classroom? I guess can I get a chat confirmation or something?
Yeah, I can access it.
Yeah, sounds good.
Oh wait, I don't have it. No wonder why I was confused. I don't have your classroom. I had level 1's classroom, so I was a little confused.
Oh, okay. Well, are you able to access it now using the code that I posted in chat?
Let me see.
Right, so once you're able to get here, just identify the file for the part that you're missing. Like in this case, for most of you, hopefully, it's just either the flywheel or the upright, depending on which one you did for homework. And just like we talked about 2 weeks in class about importing files, I want you just to have the 6 parts together in one Onshape document, or just like at least in Onshape. So I'll give you a couple minutes to take care of that. And as you get all the files into your document, just give me a confirmation. Some yes in the chat would be good. And if you have questions, just ask and we can figure things out.
Wait, how do I import the things again?
Great. So what you'll do, let's say that I need the upright. If you click that in the Google Drive, it'll give you the option to download it. So all you do is save the file onto your computer, maybe in your downloads or another folder.
Okay, but then it just like a bunch of things like edge curve and then number 112, 117.
I'm not sure what you mean.
It's not showing me like the thing. I click download and then it's like I click open and then I opened it with Word and then it doesn't show me like how you import it.
Okay, so what you might remember from class, I think 4, is we talked about importing parts from Onshape. So if you click the plus sign in the bottom tabs, like we have in the options, instead of creating a part studio or an assembly or something, we can import a part. And so if you navigate to where you saved your file, you should be able to select a step file. So for me, I just downloaded the upright and I should be able to open it. And you can just press OK.
Okay.
Hi, Daniel. I just saw your chat message. So up to this point, what we're doing right now, if you don't have any questions with the homework, I want you to go to the Google Classroom and just download the file for the part that you have not made yet. So probably it's either the flywheel or the upright, but I want you to get each part into a single Onshape document like this. So you just have each of these parts all together. And when you've done that, just let me know, say something in the chat, say something over the call. And if you need help, just ask.
I think it's going. It shows me that it was completed, but
Okay.
I don't still see the base.
Sometimes it takes a moment for it to show up after you've imported it. Give it another few seconds, and if not, we'll take a look together.
Oh, it opened it up in like another studio.
Okay. And so just do that for the part that you're missing. And when you have these 6,
Okay.
let me know. I see Daniel. Will you have access to a computer? Or I guess, are you on a computer?
Yes, but it's my mom's. The
Okay.
device I usually use is in my house, so I have to go home, and it's like 2 minutes.
So do you need a different way to get the files, or
No,
will
I'm
you be
fine.
good?
I'll be home in 2 minutes, so I
Okay,
can
that's good.
download.
Yeah, that's okay. We'll be waiting for everyone to get these files. So
Mhm.
for those of you who have already downloaded the parts and are just waiting for something to happen, maybe start thinking about what you'll do to assemble this engine together. So look at each of the parts, think about how they all go together, maybe look at the drawing from the PDF, and you can start working on it even if you feel confident. Do you have a question, Elliot?
So I just made a new document to try uploading all of them. I have it in my other one, but
Okay.
I just see it just says like base step. Like it just says step.
Okay. I'm not quite sure what you're looking at right now. If you want to share, maybe
Okay.
we can figure it out.
Oh. It just says base step.
Okay, so I see. What happens when you try download?
So wait, which one am I to say import this? Which one should I click?
Import into this document.
Yeah, I did that and I just
Okay.
clicked OK. Do I have to do any of these?
No, you don't need to do those.
Okay, I did that for all of them.
Try pressing update.
I think I know how to help you.
Okay.
Okay.
I think you should just click that home button.
Here?
No. You see right at the CAD imports on the left, there's a little house with a chimney.
Yeah.
You click that, and then you click the crank wheel, whichever one. Yeah, I had the same problem.
Okay.
Wait, so
I
I have a
do.
question.
Yes?
So after we like finished like importing like the things that you didn't do
Yeah.
you like put them all on the assembly?
Right now, just get it into the documents together. So for example, like Elliot had, or something like this, just make sure in the tabs that you have each of the parts.
Okay. All of them are on different tabs though.
That's fine. That's how it should be.
Okay.
Is everyone at this point? Could I get some confirmations in the chat or by voice? Okay, I'll ask this way. Is anyone not ready to move on with the assembly? Or do you have a problem, Peyton?
No, are we supposed to create how are we supposed to connect the skinny holes? Because I feel like the piston.
Yeah, okay, so we'll go into the assembly then. I was just asking if anyone was still having any trouble with importing the parts, but based on the response, I think we can move on. And so what we'll do, as with our previous assemblies with the U-joint or the do-nothing machine, we create our new assembly. And you can just import each of the parts by clicking on them and pressing the check mark. You'll get a visual indication of the parts just based on what you see in your screen. And when you insert them, you should have each of the 6 parts that we modeled. Great. So the first thing we want to do is kind of set the base up. And so there are kind of 2 ways that you can go about that. One way is just to fix the part. And what that means is that I can't move it anymore. It's fixed to kind of that point of space in the assembly. And that's just where it is.
Wait,
There's another way to do it, which I'll show, which perhaps may be a better way. What we can do is fasten things to the origin. And so this is the way that I would prefer to do it, because you can make the point have a point that's actually connected to the origin of the assembly. And so what I'll do is I'll click the fasten mate, and I'll just select one of these points. And for the second point,
well, I have a question. How do you like make sure that those things can't move?
that's what we're gonna do right now with the fasten mate. I was showing like an alternative way to do it is just press fix with the right click, but
Wait, which point do you fasten?
it doesn't really matter. All it will determine is where the origin of the assembly is based on what part of the part.
Which point of like the base do we fasten?
So it doesn't really matter, is what I'm saying. It could be like the center here, it could be any of the corners, any of the sides. All we want is for the coordinate system of the assembly itself, which is this point, to be in a fixed relationship with the base.
Do I solve it?
So I'll continue with the demonstration. You pick just some point on your base and the assembly origin. And something to keep in mind is that the side of the base that has the bigger holes on it, the counter bore, is actually the bottom, because the screws go up through the base into the upright. And so it's not completely critical you do it, because the coordinate system, again, of the assembly is a bit arbitrary, but just as a matter of personal preference, I'll flip it like that using the arrow. But all that really matters for this step, I could always do this if it were upside down. All that matters is that you fasten something to the origin.
I'm having trouble fastening the thing to the origin because every time I click the thing and the origin point, it doesn't move anywhere.
Okay. Do you want to show?
Wait, do we solve the fasten mate?
You can solve it. It probably won't do anything.
Okay.
All solve means is it like calculates a new position that may not be visually displayed. Right, so one thing I'll say is that you want to use the fasten mate rather than the mate connector. Right, that one.
Oh, I was confused.
Yeah. All right, so at this point, we'll have something like this. And okay, Daniel, so if you have all of the parts together in a single document, so you might have 6 tabs like this with each of the parts, the first thing I want you to do is create a new assembly and just insert all of the parts. So what you can do is just click on each one, and that'll show you visually which parts are being inserted. And if you just click the check mark, they'll all come in. And after that, I just want you to fix the base. So you can either do that just by right-clicking the base and clicking fix, or you can fasten it to the origin using the fasten mate. All right, so the next part we're going to assemble is the upright to the base. And so as you can probably imagine, these 2 holes at the bottom are meant to go with these holes in the base. And so I guess what mate do you think we can use to help us do that? Anyone?
I don't know yet. Hold on.
The fasten mate, is that what you're asking for?
Yeah, the fasten mate can definitely work. And so we'll do that. So one thing you'll notice is we're not assembling it with any of the physical hardware that we would need, like screws, but that's okay in our case because the screws don't affect the functionality of the part, which is what we're trying to show with our model here. If you wanted to, you could go, for example, to McMaster and download the CAD file for the screws, as we talked about how to do 2 weeks ago. And just like we're doing right now with the bigger parts, we can mate the hardware in as well. But like Peyton said, we're going to do a fasten. You can pick one of the circular outlines and another circular outline. And there's a good chance you might get something like this, which is clearly not what we want. And so the way we'll fix that, first of all, we'll flip the mate alignment using this double arrow, which gives us something better. It is in the correct general place that we want it, but it's not quite clocked the correct way. And so what we can do is orient the secondary axis, and I'll click that until I have what looks right to me. I can see the holes are aligned for both of the holes. Peyton, do you have a question?
So when we fasten it, so for the base, are we going to fasten it with the big side or are we going to fasten it with the skinnier holes?
So like I mentioned before, the side with the counterbore with the larger holes is technically the bottom. And the reason these bigger holes exist is so that the head of a screw can go inside of it without having to stick out the end. So if you can imagine, we would be putting a screw in like this, and so the bigger hole would have to be at the bottom rather than being covered up by the upright. Does anyone have a problem up to now?
It's not much of a big problem. It's just that it keeps going on the big holes rather than the tiny ones.
I'm not sure what you mean. Do you want to
I
show
want
with
like
us?
the big hole side rather than the tiny hole side.
Okay, so if it's a problem where the upright is not detecting the correct side of the base, then it's just a matter of flipping the alignment of the mate. So this is something you can do if they're going through each other, this is something you should do.
Wait, what do I fix again? Which part?
So you can either what we want is to have the base be fixed relative to the assembly's
Okay, the
coordinate
base.
system. Yeah,
Got it. To the origin?
yeah. Just anything is fine. Something like this or another point.
Wait, does it have to be next to the origin, or can it just
You can also
like
just fix it like that.
alright.
All we want is for the base to not move relative to the assembly. Peyton?
I need to make it move 90 degrees so the two holes can match up. Can you show that again?
Sure. So right now you have something like this. Yeah, so what you can do is reorient the secondary axis, and assuming that you picked like one of the bottom holes, that's what'll fix that.
When I try to do it, those two, like it goes on the opposite way, and wait, what are those called? Like the base and the it's like that. It
Okay.
turns out like that.
So what you would do in that case is
Do
just
I use a fasten mate to tie the I use a fasten mate, right? Or do I use a planner?
we're using a fasten in this case since
Okay.
the upright will never move relative to the base.
Good.
And whoever asked the question before, I hope this answers it. You can just flip the primary axis, and if you have Baton's problem of it being oriented the wrong way, you can also change the secondary axis.
Okay, thank you.
Okay. So if there are no more problems with that part,
Wait, how do you know if it's like oriented the wrong way?
in the end, it should look something like this, with the upright standing upright on top of the base. By the wrong way, it just means something like
Okay, never mind.
if it's like turned 90 degrees.
I got it. Thank you.
Okay. So what we'll put on next is the cylinder. So this one is the cylinder, if you remember. And the way it attaches to the upright is that this hole, kind of the one in the middle, is related to this hole, the one that's kind of in the middle of the cylinder. And in this case, we want it to be able to rotate with respect to each other, but not to move in and out. So we'll use a revolute mate. And what you'll do is you'll select this middle hole of the upright, as well as this middle hole of the cylinder. And as with the upright and the base, you might get something like this that you don't want, where the parts go through each other. So you just do a flip of the primary axis.
Can you show that again? I just finished
Right.
the fasten and
So to just go through that again is we're using a revolute mate because we want them to rotate with respect to each other, but not move in and out. And we just pick the middle hole of the cylinder and kind of this middle hole of the upright. And those are the holes that we want that are together. But since we don't want them to go through each other, we will tell it that it's actually this way. We flip the primary axis, and that's all we need. So the result should be that it can spin around like that. Does anyone have problems up to here? If not, I'll move on to the piston. So for the piston, it's kind of going to be moving in and out of this hole in the cylinder. And so in this case, we're going to use a slider mate. And what we'll select is kind of one of the axial faces of the piston, as well as the circle for which the piston goes into. And we'll just get something like that. We want the piston to be able to go in and out of the cylinder. If you make the mate, it'll move something like that.
Oh, I put it the wrong way. The thick side is on the outside.
All right, in that case, as you've seen a couple times before, all you have to do is flip the primary axis. So if no one has a problem with that, we'll move on to the next mate. Again, we're going to use the revolute mate, and this time we're attaching the crank wheel to the upright as well. And so the part that goes onto the upright is kind of this middle hole of the whole thing. And it's going into this hole in the upright. Again, if you have parts going through each other or going the wrong way, just need to flip the primary axis and it should be good. And the result of that is that you should be able to spin the crank wheel and you should not be able to move it in and out. Are there any problems up to now?
This is just a question out of nowhere. Can you 3D print a 3D printer?
Yeah, so obviously not every single part in a 3D printer can be 3D printed yet, at least with what we'd refer to like conventional plastic 3D printers, but there exist 3D printers where many of the parts are actually themselves 3D printed. So I think one of them is called this Lulzbot. And so you can even see like in these pictures, some of these parts are clearly made out of 3D printed parts, which is pretty cool since you can repair, I guess, your 3D printer using itself. I'm sure that's not the only one that's out there, but that's a specific example of one that does that. And this goes to show you what 3D printing is capable of.
My wheel thing is like just stuck inside. Wait, let me show you.
All right.
Can you see it?
I can see it.
Yeah, it's like
So what might have happened there is you may have selected a mate connector that was inside of the crank wheel. And so there are two ways you could solve it. One of them is to create an offset, and the other might be just simpler, just delete the revolute mate that you made last. So in the left tree, kind of at the very bottom, the second revolute, right? You can probably just delete that and make it again, and hopefully it'll work. Just drag the thing out, the crank wheel away from the upright, and make sure you select the bottommost face. So the one that's in plane with the bottom face of the circle, yeah. And that should be good.
thank you.
All right, if there's no other problems, I'll move on. The next thing we want to do is to take this hole in the piston and connect it to the smaller hole in the crank wheel. For this one, we'll use, not a slider, we'll use a cylindrical mate. And what you want to do, just select this circle as well as As well as that circle and the crank wheel. I'll just do it one more time. When you're selecting the circle here, make sure you pick the one that's going to be perpendicular. And I expect
Wait, which hole do we connect it to? Like, which hole do we connect the cylinder to?
the cylinder.
No, I mean, like, which hole do we connect that rod or something to do?
Right, so I'll show this one again. What you want is to select this hole in the piston, and you kind of might have to zoom in so that the circle is in the same axis as the hole itself, like so. And also pick this circle on the crank wheel. If you made them together, you'll have a relationship like this.
Can I share screen? Mine is kind of weird.
Okay.
Okay. So, this happened to me when I was doing it.
Yeah. So again, it's a similar problem.
It's like,
could you undo the last cylindrical mate? So in some cases, there are like multiple possible solutions geometrically to the mates that you assigned. First of all, you might want to check your slider mate to make sure that it's in the correct orientation.
I think it is.
The larger part of the piston should be going into the cylinder.
Oh.
Yeah, so you might want to flip that.
Then, like that?
Yeah, that looks good.
Okay, that's how I had it before.
So then pull the piston out of the cylinder. Or, sorry. It's still in the wrong direction, so I guess go back to the slider mate. Yes, that should be the correct orientation. And so hopefully now when you drag it, it'll go in and out of the cylinder. Okay, and what you want to do now is to apply your cylindrical mate between the pinhole in the cylinder, or in the piston. You might zoom in a little bit and get the circle. Try hovering your mouse over the plane. Yeah, there. And the hole in the crank wheel.
And then this happened again.
So what you do here, first of all, just try like solving it. Okay, try flipping the primary axis and then solving it.
Everything is like red now.
Right. So yeah, that can happen. What I recommend is to delete the cylindrical mate. And what we can kind of do is guide it towards the correct solution by moving it closer to the final desired position. So kind of click on the cylinder, the box, yeah.
Let me just move it. Yeah. And this happened again.
I think I know how to fix this problem.
Okay, Peyton.
So I think from what I was seeing on his screen was that he was clicking the circle for the little piston, he was clicking the circle on the outside, not the one inside, from what I saw. So like the one that I think he should do the one that's behind on the piston, not the one that's looking straight to it. So I might have to turn his screen, do the one behind it,
Try
and
that.
then
Oh god. This one? Or like the one in the middle?
no, the one right on the edge, right there. The
Oh,
yeah,
this one?
yeah,
Okay.
and then now you click that hole.
And it happened once again.
Try accepting it. Sometimes it doesn't look right before it is right. Yeah, so it worked. Or I guess it did not work. So this is technically, you can see that it's like each of the mates themselves is correct because the relative direction of the piston and the cylinder is correct. It's just that it found the solution that is not the one that we want.
I kind of want to do that.
So
Now it's not sliding inside of it.
one thing that we could try is to get rid of the slider mate and to apply that one afterwards. And perhaps you might be able to find the solution.
Wait, so get rid of the slider mate into the cylinder first?
Right, so just delete the slider.
Okay, backspace. Okay, and then cylinder mate.
So first make sure that the current, yeah, okay.
No. Okay, so this one,
Yes.
and then and then this one.
Okay, that should work.
I think. Oh, what? Okay, something just happened. So cylinder, we have to pull this out.
For everyone else, there's just one mate left, which is the flywheel, and it goes along the same axis as the crank wheel. So see if you can figure out how to do that yourselves.
Okay, so first over there, and then now accept that. Okay, so now it's on there. Now we should. Whoa, this is super far away from my.
Yeah, so that's because we picked a cylindrical mate this time, but you can just drag it back to be closer.
Okay, so again the slider.
So in this case, for the slider mate, we're doing the piston face into the hole.
And then we click bottom, right?
Right, you could do that one.
And now the surface of this.
Right. You'd want to flip it, the primary axis. Or no, I guess I saw the wrong thing. You flip the primary axis, the secondary axis does not matter. And if you solve this, it should be correct. There, we got it. So yeah, what this shows, I guess, is that CAD software won't always do what you think it will, even if you think that what you expect is the only possible outcome.
Yeah,
But
pretty good.
as long as you change what you're doing, maybe carefully examine you'll eventually arrive at the solution.
Okay, thank you.
Now, those of you who are astute and observant may have noticed that I put this crank wheel on backwards, which is just a careless oversight on my part, but the exercise is left to you to reverse it so it looks like that, maybe at some later time. The last thing to mate together is, of course, the flywheel. And as before, we're going to use a revolute mate. You'll notice with the flywheel that one of the parts protrudes outside of the plane of the edge of the flywheel. So just on the side where it sticks out a little bit more, we want to pick the circular face, as well as the corresponding circular face on the upright. And if it goes through, as usual, flip primary axis, and you'll have this relation made. And since the class is almost over, I just want to show you one last thing, and I can take questions afterward. There's something called the group. And so you'll notice the flywheel is not actually connected to anything on the other side because we didn't actually model things like the crank pin that go through that would exist in real life and constrain them together. So what you can do is just group, which is this tool in the middle of your toolbar. And if you group the flywheel and the crank wheel together, you just click them, then they'll start to move together. So that lets you do is to control the movement of the flywheel from the other side. At this point, the assembly is complete, except for the small matter of this part being backwards, but I'll leave that to you maybe as homework, or on your own curiosity, you can figure out how to change that back. So Peyton, do you have a question?
Yeah, so for the group ones, which holes do we click, or do we just click the whole solid thing?
The group will just take parts, so you don't need to click a specific feature. You can just take the entire part that gets highlighted, and that will group them together. So their motion will be relatively fixed. At this point, it's 7 o'clock, but I'll stay behind if anyone has specific concerns. One last thing I want to mention is that next week, we're going to be talking more about 3D printing topics. Actually, Jack will be talking about 3D printing topics. This is my last class for the CAD 2 class. So it's the last time I'll be seeing you for now. And the project that you might want to start thinking about, that will be the last project for the class, is designing a small keychain for 3D printing. So it's going to be roughly maybe 2 inches cubed. And just think about ideas for things that you might want to make or design.
Eugene?
Yes?
So for my thing, I'm just asking this about 3D printing, but is this 3D printable?
This steam engine or air engine?
What?
Are you talking about this?
Yeah, the
Yeah.
whole thing. Is this 3D printable and
So,
actually workable, like in the assembly?
right. So every component of this engine can be 3D printed. Like there's no geometry in any of the parts that would prohibit it from being 3D printed, though the original drawings were meant for metal parts because it indicates certain features for screws and such that would suggest that. But each of these parts would independently be 3D printed, and then you would assemble them together with your own fasteners.
Also, I need like some fasteners to like, or like mini poles to like attach them all together.
Right, you would need something. So there are a few parts that could be printed together. For example, the upright and the base, if you had enough room in the 3D printer for that kind of clearance, you could print together. But for the most part, you would need other fasteners.
Oh, okay. Thank you.